Okay, so it says you have a tungsten. The tungsten is a body-centered cubic cell. So it's body-centered cubic BCC structure. And the question asks you, what is the packing efficiency? So basically, it asks you about the space efficiency. So first, we can draw a BCC unit cell. That is a cubic. For the body center, we know the atom will occupy at the corner, and there will be one that actually occupies at the center. Of course, each atom is a spherical-like. So for the body center cubic, if you make some drawings, you will find that in the diagonal line, all the atoms touching each other has a direct contact with each other. So that means if we assume the radius of the atom is r, the diagonal line of this cubic, of the cube, right? The length here equals to what? Since in the diagonal place there are 1, 2, 3 atoms, and the center one is a full atom, and the corner one is only 1/2 of the atom. That means the diagonal line, the length of the diagonal line should be 2r plus r plus r, so equals to 4r. And from here, we can calculate the length of the edge, right? Because the diagonal line square equals to the length square plus length square plus length square, and square root this part. So that means the diagonal line will equal to square root 3 times L. So the L here will be LD over square root 3. So it becomes 4 over square root 3 times the radius. So from here, what we can calculate is the volume of the cell. That's equal to the length of the edge power 3. So it becomes to 4 over square root 3r power 3. That's equal to 3 times square root 3. And the numerator is 64 R3. And now we need to calculate how much space that the atom occupies. For the BCC structure, 8 corners has 8 atoms, but each atom was shared by 8 cubes. So that means as a corner, you have 1/8 times a atom. And in the center, it's shared by only 1 cube. So plus 1. So that means you have 2 atoms in the unit cell. From here, we can calculate the volume of the atom that occupies here is equals to 2 times the volume of the 1 atom here. So that's equal to, since the atom is sphere, so that's 4/3 times pi r power 3. So that's equal to 8 over 3 pi r 3. So now we can calculate the space efficiency. That is the volume of the atoms occupies over the volume of the cell. So that's 3 thirds pi r power 3 over 64 over 3 times square root 3 r3. So we can cancel some parts. You find this can become cancelled, r can become cancelled, right? And that becomes 8 pi over 3 times 64 times 3 times square root 3. So here 3 can be cancelled. 8 can be cancelled to 8. So it becomes square root 3 times pi over 8. And that's equal to about 68%. So this is the answer. It actually has nothing to do with the density or molar mass. That's it.